All right, Algebra 1A students. Welcome to part 1 of lesson 1-3. Today we're going to be talking about what it means to basically undo squaring something. Okay, so remember that 5 to the second power with this little 2 up above there, 5 to the second power means to multiply 5 by itself again, right? 5 squared, 5 with the little 2, 5 to the second power means 5 times 5. So 5 times 5, 5 squared, is 25. Now, if we want to go backwards, to go from 25 to get 5, or from 9 back to get 3, right? We know 3 times 3 is 9. Or from 16 back to get 4, we know 4 times 4 is 16. We have to do the opposite of squaring something. Okay, the opposite of taking a number and squaring it, like we did up here, 5 squared. The opposite of that is called square rooting something. Taking a square root of a number, okay? So the square root of a number is just what number do you have to times by itself to get to that number, okay? So the square root of 49, well, if we think about what number we have to times by itself to get to 49, it's not 3 times 3, it's not 4 times 4, 5 times 5, 6 times 6, it's 7 times 7 makes us 49. So the square root of 49 is 7, okay? It says it's a square root. We'll actually get to much later in this chapter the fact that there's a positive and negative, but for today, we're just worried about the positive numbers. So we go from 49 back to 7, right, by taking the square root of 49. And we're just asking ourselves, okay, what number do I have to times by itself, multiply by itself again, to get 49? And in this case, it's 7 times 7. So 7 is the square root of 49. Okay? So square roots are an example of a radical. Okay? So there's a couple pieces to a radical. There's a radical symbol and what's called the radicand. Okay, the radicand is a number. Okay, the radicand is a number. The radical symbol is a symbol that looks like this. Okay, so if I make that symbol and I put in there 64, I put 64 in my radical symbol here. This together is a radical. Okay, so I have a radical symbol and a radicand, a number underneath. Together they make a radical. Okay, we could do it again. We could say square root of 81. Okay, we could say really the square root of any number that we want to. We could say the square root of 15. That's not an easy one to find, which we'll talk about in a second, but all of these are examples of radicals, okay? Radical symbol, and then a number underneath called the radicand. So once you have a few examples of radicals down in your notes, let's go to the next slide, and let's actually start simplifying some of these. Let's actually start finding some of these square roots here, okay? So when we're asked to simplify a radical, it basically means if we can to find a one number answer or sometimes a fraction answer, and we'll talk about fractions here in a second. But first, if they ask you to simplify here in letter A, the square root of 81, you have to ask yourself, what number do I times by itself to get to 81? Okay. Now we can check this on a calculator or on paper, but hopefully we can do in our head the fact that, well, 6 times 6 is 36, so we have to go higher than that. 7 times 7 is only 49, like we just talked about. 8 times 8 gives us 64, which isn't quite high enough, but 9 times 9 does give us 81, right? So 9 squared, 9 times itself again, is 81. So the square root of 81 then is 9, because that's the number that we times by itself to get 81. Okay, so the square root of 81 is 9, right? So based on that, you guys should be able to do letter A right here and letter B right here. But C and D our fractions. So we have to look at this example here first. The square root of 9 over 16. Okay, the square root of 9 over 16. The good news for us is when we have a fraction under a square root, we can just take the square root of the top and the bottom totally separately, and that's how we find the square root of a fraction. So when we have 9 over 16 under a radical sign, under a square root sign, all we have to do is look at the top number, which is a 9, and ask ourselves, what number could I times by itself to get 9? And that answer is 3, because 3 times 3 makes 9. Okay, so the square root of 9 is what gives us the 3 here. And then the square root of 16 on the bottom is what gives us the 4. Right? So the square root of 16 is 4, because 4 times 4 gives us 16. All right, so 3 over 4 is the square root of 9 over 16. Okay. So now you should be able to do part A, B, C, and D here and got it, number 1. Find me the number answer for each of these square roots. Okay, maybe not letter D, but we can certainly do letter A, letter B, and letter C, I believe. Okay, so take a look at those, pause the video for a second, try to figure out those, and then come on back and I'll show you what we should get. Okay, in letter A, the square root of 64 is 8, because 8 times 8 gives us 64. The square root of 25 is 5, because 5 times 5 is 25. And then here, when we deal with our fraction piece, the square root of 1 over 36 is, well, on the top, 1 times 1 would give us 1, so the square root of 1 is always 1. That's a nice easy one. It doesn't change. And then 6 times 6 would give us 36 on the bottom. So the square root of 1 over 36 is 1 over 6 as a fraction. Okay, so letter A is 8, letter B is 5, and letter C is 1 over 6. All right. Now, all of these numbers that we've been taking the square root of so far have been very nice. They come out nice and evenly, like the square root of 81 being 9, the square root of 64 being 8, the square root of 25 being 5, and so on and so on. There's no decimal, okay? But if we try the square root of 90, we get a decimal answer. Let me show you that real quick here. I'll bring up my calculator, and we'll do the square root of 90, and we should find that it's a decimal that's like 9 point something, okay? Also, if you don't know how to do the square root on a calculator, pay close attention to what I do right here. You'll notice that on my calculator right here, I have an x squared button. Okay, this is an x squared button. And up above there in little blue writing, I don't know if you can see it here, but there is a radical symbol, a square root symbol. So to get to the blue stuff, I have to hit the blue button here. So I hit second, and I hit x squared, and it brings up my radical symbol on my calculator screen here. And then I just punch in whatever number it is that I want to take the square root of. And here I wanted to take the square root of 90. So I take the square root of 90, and I hit enter. And you'll find that I do get some decimal number that's very long and complicated, right? It does not come out evenly. I end up with a decimal number here. So what that means is that this square root is not one that we just need to know. It's not one that we can just come up with, because it'd be very difficult to come up with the fact that 9.4868 times itself again equals 90. Okay, so square roots that do not come out evenly, we're not going to deal with too much, at least finding the actual decimal answer yet, unless we use a calculator, which we'll do tomorrow. But we do have a special name for numbers that have nice square roots that come out evenly with no decimals, like these did up here. And those are called perfect square numbers. Okay? Perfect square numbers are numbers that when we take the square root, we end up with a nice even number. Okay? And examples of that would be like the square root of 36. We know that's just 6. That's very nice and easy. Same thing with like the square root of 81, which we looked at before, being 9. Okay, so those numbers are called perfect square numbers because they're perfectly some number with no decimals squared. Now, in your practice problem set tomorrow, I am going to ask you to estimate square roots like this one up here. Okay, I'm going to ask you to estimate square roots like that by just thinking about our perfect square numbers. Okay, perfect square numbers. So it's going to look like this, where it asks, what is the value of the square root of 34 to the nearest integer? Integer means no decimal, a nice whole number. Okay, so if I look at my calculator, the square root of 34 is not a nice number. It's kind of a random decimal, 5.8 something something something. But if we think about the perfect square numbers that we know, that are somewhere around 34, if we just go up the list and we start listing off numbers like 1 squared being 1, 2 squared, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and so on like that. We end up with this list of numbers that are perfect square numbers where we know the nice number answer when we take those square roots. Okay, so what we can think about is, well, 34 would land somewhere in between 25 and 36, right? It would be somewhere in between there. So what is the value of the square root of 25? Well, if we take the square root of 25, we know that that answer is 5 because 5 times 5 is 25, right? And what is the value of the square root of 36, which is our next nice number? Well, that's 6 because 6 times 6 is 36. So we know that the square root of 34 must be somewhere in between 5 and 6. Okay? And the only question for us is, which is 34 closer to? Is it closer to 36 or is it closer to 25? The answer is it's closer to 36, which means the square root of 34 is very close to 6. Okay, that's a good estimate for the square root of 34 because 34 is so very close to 36. Okay, so what I would like you to do then is try to find an estimate to the nearest integer for me for the square root of 50. Okay, the square root of 50. What I'd like you to do is use this list of numbers that we put down up here. Make sure that this gets in your notes as well. Make sure it gets in your notes, okay? The fact that this is 1 squared, right? And then 4 we got from doing 2 squared, and then 9 we got from doing 3 squared, and so on and so on and so on, okay? So all the way up to 64 we did by doing 8 squared. Okay, so make sure these numbers get in your notes and their corresponding square roots, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 7, 8. And then use these numbers, please, to try and find the square root of 50 to the nearest integer, the nearest nice whole number with no decimals. Okay, so pause the video, try to figure that one out using these numbers, and then coming back, I'll show you what we should get. Okay, now the square root of 50 lies for us in between 49 and 64, right? And 49 is 7 squared. It's 7 times 7. So the square root of 49 is 7. And then the square root of 64 is 8. So we know that the square root of 50 must be somewhere between 7 and 8, because those are my square root numbers from the perfect squares close to 50. And obviously 50 is much, much closer to 49 than it is to 50 or 64, right? It's only 1 away from 49. So that means the square root of 50 is going to be very, very close to 7. Okay, so the estimate that we would have for the square root of 50 is 7. Right? If you have questions about finding square roots using this list of numbers and even going up maybe to 81 and 100 as well, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you tonight. Have a wonderful night.